Good evening. Welcome to
Math for Kids number 119.
Math for Kids number 119. How to simplify square roots. So today, step in a little bit. So today we had something to do in the morning, right? So we didn't get to do our usual math in the morning. So instead of making our usual kind of fun video about stuff like what have we been doing lately? Probability. Today we're going to do something we would have done normally, and this is a problem out of the Art of Problem Solving Prealgebra book.
A little bit ripped.
A little bit ripped because we have worked hard in this book, haven't we? So we're on the square root section, and we're going to talk about just this one problem today: how to simplify square roots. So, well, let's do as much as we can with this and see how it goes. We have the problem: simplify the square root of 50 minus the square root of 18 minus the square root of 8. And what's the one thing we've kind of talked about square roots?
You can't subtract square roots.
Yeah, addition and subtraction with square roots doesn't work super well, so we have to figure out other ways to simplify. Maybe before we do the addition, but we can't just do the square root of 50 minus the square root of 18. So, what do you think? What do you want to try?
This is the square root of 2 times 25 minus the square root of 2 times 9 minus the square root of 2 cubed.
Okay, so I'll write that out. The square root of 2 times 25 minus the square root of 2 times 9 minus the square root of 2 cubed. Very interesting. Now, why is this helpful to us? Why does this help us maybe simplify this?
Because we know what the square root of 25 and 9 are.
Ah, okay. So how can I deal with this expression?
It's the square root of 2. It's the square root of 2 times 5.
Why?
Because this is the square root of 2 times the square root of 25, which is the square root of 2 times 5.
Okay, so I'm going to write it as the square root of 2 times the square root of 25 first, just to be careful, okay? You can split apart the square root. The square root of 2 times 25 equals the square root of 2 times the square root of 25.
Yep.
So you can break it apart when it's multiplication, just not addition, right? Okay, what does this equal? The square root of 2 times 9.
It's the square root of 2 times the square root of 9.
Square root of 9, okay. And then now this one is a little tricky. The square root of 2 cubed.
It's the square root of 2 squared times the square root of 2.
Ah, very good. Square root of 2, I'm going to write it as the square root of 2 times the square root of 2 squared. Okay?
Okay.
Now, what can we say about this expression here?
The square root of 2 times 5.
And how do we usually write that?
5 times the square root of 2.
5 times the square root of 2. Very good. Minus, what's this one?
Minus 3 times the square root of 2.
3 times the square root of 2.
Minus 2 times the square root of 2.
2 times the square root of 2. Well, that's interesting. Okay, so now we have 5 times the square root of 2 minus 3 times the square root of 2 minus 2 times the square root of 2. What do you want to do with this?
Well, subtraction isn't commutative.
No, subtraction is not commutative. That's true.
Now what can we do?
Yeah, now you've never seen an expression like this. So what do you think? What do you think you want to do with it?
We can just go ahead and subtract. We can't subtract square roots.
It's actually tricky to figure out what to do here.
Yeah.
What do you think it would be if you just went ahead and subtracted? What do you think 5 times the square root of 2 minus 3 times the square root of 2 is?
It's 2. The square root of 2 minus the square root of 2.
Subtraction definitely doesn't work like that. What if this was 5 times 7 minus 3 times 7 minus 2 times 7? What would you do here?
Well, we can't move these around.
No? What would you do?
I would do this part first.
Okay. It's 5 times 7 minus 3 times 7. What's that?
We have to actually evaluate it.
You don't have to, but is that what you want to do?
Yeah, we could.
Okay.
It's 35 minus 21.
35 minus 21 minus 14.
Yeah.
Okay, what's that equal to?
It's actually 0.
That's actually equal to 0. That's interesting.
So maybe this is equal to 0.
Maybe it is equal to 0. What if I did this? What if I, do you remember the distributive property?
Yep.
What if I factored a 7 out of all of this? And I said this is equal to 5 minus 3 minus 2, whole thing times 7.
Well, 5 minus 3 is 2 minus 2 is 0 times 7, which is 0.
Which is 0 times 7, which is 0. Now what do you think I could do with this expression?
Factor out a square root of 2.
Factor out a square root of 2 out of everything. That's one approach. So I have square root of 2, and then I have 5 minus 3 minus 2 times the square root of 2, which is
0 times the square root of 2,
0.
which is 0.
So we have actually, we just learned something. The square root of 50 minus the square root of 18 minus the square root of 8 is equal to
0.
0. Now let's see if there's another way we could have seen this. What if I had written it a little bit differently? 5x minus 3x minus 2x.
This should equal 0x.
Right. We could do 5x minus 3x, which is 2x, minus 2x is equal to 0. So what do you think 5 times the square root of 2 minus 3 times the square root of 2 is?
Well, 2 times the square root of 2.
2 times the square root of 2, because 5 times anything minus 3 times that same thing, 5x minus 3x equals what?
Equals 2x.
2x. So 5 bananas minus 2 bananas equals, sorry, 5 times banana minus 3 times banana equals 2 times banana. But 5 times the square root of 2 minus 3 times the square root of 2 is 2 times the square root of 2. So once I do that, and I do 5 times the square root of 2 minus 3 times the square root of 2, and I get 2 times the square root of 2 minus 2 times the square root of 2, what's that equal?
0.
0. So the only time you can add square roots is when they're the same square root. Okay? Then you just do the regular, just like it was an x. 5x minus 3x is 2x. 5 times the square root of 2 minus the 3 times the square root of 2 is 2 times the square root of 2. Make sense?
Yep.
It's pretty good for not having ever seen how to do a problem like this before. Were you surprised that the square root of 50 minus the square root of 18 minus the square root of 8 equals 0?
Yeah.
Yeah. Yeah. Let's see if we can figure out maybe a little bit why that's true. Just take one extra minute. The square root of 50 is really close to what number?
It's really close. Well, 5 squared is 45.
What?
No. Oops.
What?
No.
5 squared is what?
5 squared is 25.
5 squared is 25.
Well, 7 squared.
7 squared is 49. So this is really close to 7. Is it bigger than 7 or less than 7?
Tiny bit bigger than 7.
Okay, so I'll write this as 7 plus squiggle. A little bit bigger than 7, okay? Square root of 18 is about equal to what?
Well, it's about equal. It's a little bit bigger than 4.
It's a little bit bigger than 4. So I'll write this as minus 4 plus some other squiggle.
It sort of looks like Aleph.
Sort of does look like an aleph. Okay, square root of 8. What's that?
Well, that's a little bit less than 9.
Okay, so the square root is a little bit less than
3.
3. So minus 3 minus a squiggle. How about a squiggle like that? Okay, so this is equal to 7 minus 4 minus 3
We can't factor a squiggle.
plus little number minus little number plus little number. Right? So this is 0, right?
Yeah.
And then some little number. So this just tells us, looking at it kind of in a silly way like this, that this is really close to 0. This one's a little bit bigger than 7, minus something that's a little bit bigger than 4, minus something that's a little bit less than 3. So we can tell right from the beginning that it's kind of close to 0. But in fact, if we do work through the math carefully, we can find out that it's in fact exactly equal to 0. That's pretty neat, right?
Yeah.
Okay, good job tonight, honey. Good job.